find a real non-zero solution to this given equation. In this given equation, we have 2 to the power of 9 to the power of x divided by 8 to the power of 3 to the power of x equals to 1 over 4. So we are interested in getting the non-zero solution for x. Now let's break this down. Here we have 2 to the power of 9 to the power of x divided by 8 can be written as 2 to the power of 3. And outside this, we have 3 to the power of x, which is equals to 1 over 4. And from this, here we have 2 to the power of 9 to the power of x divided by 2 to the power of 3 times 3 to the power of x equals to 1 divided by 2 to the power of 2, which is equivalent to 4. And from this, here we have 2 to the power of 9 to the power of x. Using the rule of indices, this is going to be minus 3 times 3 to the power of x, which is equals to 2 to the power of negative 2. Here, I'm going to use this rule of indices that says a over b. Okay, or let me say 2 to the power of a over 2 to the power of b, which is equivalent to 2 to the power of a minus b. So this is what I used. Now, another rule of indices says that a to the power of m equals to a to the power of n. If the bases are equal, you can easily equate the powers together. So here, my powers here is 9 to the power of x minus 3 times 3 to the power of x equals to negative 2. Now, rewriting 9 to the power of x as 3 to the power of 2. X outside minus 3 times 3 to the power of x equals to negative 2. From here, I can easily switch my 2 for x. So that is 3 to the power of x, 2 outside. This is also very correct using the rule of indices. And here I'm going to have 3 times 3 to the power of x equals to negative 2. Next, let y to be equals to 3 to the power of x. So we're going to plug in y to the power of 3 to the power of x. That is, here is going to be y, and this is also going to be y. So here, I'm going to have y to the power of 2 minus 3 times y equals to negative 2. Rewriting this given equation here, we're going to have y squared minus 3y, moving this negative 2 to the side. Here I'm going to have plus 2 equals to 0. Solving quadratically, using the normal quadratic equation, we can use the factorization approach. So here I'm going to have y squared minus 2y minus y plus 2 equals to 0. How do I get that? You look at, here we have negative 3y, we have positive 2. So here, you look at something that, okay, when you add them together, you're going to get this, and the product is going to give you this. So 3 can be splitted as 2 and 1. Now, to get positive 3, so it's either you multiply positive 2 and positive 1, but with that, adding positive values cannot give you negative 3. So negative 2, negative 1 is going to give you negative 3, and the product is going to be positive 2. So this is why I'm using this. Now, proceeding from this by factorization, I can factor out y. So here I have y minus 2. Here minus 1. Here I have y minus 2 equals to 0. So by factoring out y minus 2, y minus 2, which is common to both sides, I have y minus 2. And outside the parentheses, we have y minus 1 equals to 0. So here, you can say that y minus 2 equals to 0, or y minus 1 equals to 0. So we can say that y equals to 2, or you can say y equals to 1. So in this case, I'm going to say my y1 is 2 and my y2 is equals to 1. Don't forget, we've been only able to solve for y. But the question says the real non-zero solution for x. Recall that y equals to 3 to the power of x. Since y equals to 3 to the power of x, so here for y1, which is 2, equals to 3 to the power of x. And for y2, we have 1 equals to 3 to the power of x. Now let's solve this. For case 1, here we have 2 equals to 3 to the power of x. To get the value of x, we can apply log to both sides. So solving this further, here I'm having log 2 equals to, moving this behind, I have x log 3. Now, both sides can be divided by log 3 log 3. And with that, I can say that my x equals to log 2 over log 3. And finally, you can say that your x is log 2 base 3. This is case 1. What about case 2? For case number 2, recall that we have 1 equals to 3 to the power of x. So here we have 1 equals to 3 to the power of x. Instead of using logarithm, here you can say that 1 can be written as 3 to the power of 0, which is equals to 3 to the power of x. So here we have x to be equals to 0 here. And this case is not possible. Why? Because we are interested in the non-zero real solution. So conclusively, our x is log 2 base 3. Thank you very much for watching my videos. Please, if you find this very insightful and very helpful, kindly subscribe to my channel. See you next time. Bye.